Right, everyone, welcome back. Hope you've all got some caffeine in your bodies to wake you up for the next sessions. We'll start without having much delay because we have lunch after this session, so I don't want to hold up everyone between now and lunch. Next up, we have Manuj Marwaha. I hope I pronounced that correctly. He's going to talk about too much data is no information. So, please, welcome onto the stage.
Hi guys, it's really amazing to be here today. This is my first opportunity to be part of MENOG. And I'm Manuj, and I've been part of this industry for almost 2 decades now. And trust me, and talking to such progressive bunch of people and curious bunch of people I think it's amazing. I never thought and realized that this is going to be at this level. We talked about sanctions, we talked about quantum physics and how quantum mechanics can influence the future as well. It's amazing. So my discussion topic today is too much data is no information. As you know, data is growing at crazy levels. I don't even want to talk about how many billions of bytes, zettabytes are. Look at the rate. It's crazy number, mind-boggling number. And service providers, they play a very critical role. They are providing and bringing millions of subscribers with their last mile of connectivity. I feel the pain for them. So much is changing. The technologies are really evolving, and they have to maintain the legacy systems. At the same time, they have to embrace the change. And it's really fascinating that the people they have the same set of people to handle all that change. It's not an easy task. And trust me, I think everyone can vouch for it. There's not even a single day where we don't learn so much, right? There are new paradigms that are coming into the play. The applications, they were once upon a time just limited in the data center. They are all over the place now. There are multiple public clouds that are available. And on top of it, as you know, because the user behavior has changed. Look at what COVID has done us. A lot of people are still working from home. And we have subscribers or users spread across various boundaries. And still, we feel the pain that service providers have to go through. They have to address a lot of problems to bring visibility and solve problems for the users. Right? This is not an easy or a trivial task. And as we are embracing newer technologies, we have been talking about 5G systems coming into play, changing the whole humanity all over again with their higher data rates and lower latencies and different use cases. Look at what we are in the middle of. It's becoming cloud native. We need to understand what exactly is cloud native, not that easy to understand or comprehend. On top of it, the whole encryption game is changing. Now we have network functions in the cloud who are sending data which are encrypted. And the service providers need to have visibility, because if you cannot see things, how can you manage things? How can you solve problems for your users? It's not an easy task. Also, vendors have a different way of implementing the specs. We all know that it's not an easy task. How we bring the vendor independence into this equation. And on top of it, in the cloud, there are lot of newer complex way of plumbing that is seen. For example, IPv4, IPv6, it's a debatable thing. We have a lot of complexities because of that. On top of it, in the cloud, there is a lot of natting that is happening. So how do we make sense of so much of data to bring visibility and solve the problems? It's not easy. So what exactly is being cloud native? You would have heard Kubernetes or the orchestration layer, how things are changing, how we want to spin off more resources or more pods on demand, horizontally scale the solution based on. So all this automation and cloud native function is causing a lot of chaos. And if you see, on top of it, we have other way of doing things as well. There is network slicing happening, edge computing happening, crazy days. So let's figure out what exactly is cloud native, right? So if you see here, we have multiple hosts, right? And multiple hosts can make up a cluster, right? For example, I'm showing you here right now is a Kubernetes cluster where there are various network functions, and every function has a different pod. If you see here, on the multiple hosts, we have different pods. And if the traffic increases, these systems are autonomous. They spin more pods. And it can actually happen on anywhere on the cluster. So how do we make sense of that data that in this very, I will say, dynamic environment, right? So we as a part of a solution provider, we need to make sure that we need to enable these service providers so that they can make sense of the data and can solve the problems, right? These are, by the way, these are very not easy problems to solve. We need to bring east-west visibility. In these times when various functions and microservices are there is a lot of interaction happening. We, as we were rolling out services like VoIP or voice over LTE or voice over new radio, the aspiration was to make it simplified. But that is not the case when we see it in the real world. There are a lot of nodes talking to each other, a lot of problems that we see, and we need to figure it out quickly. Look at the scale of the things. When we have so much of data, it is so difficult to find those needles in the haystack. At these mind-boggling data rates, the problem is really more difficult. The problem actually rises exponentially. So we, as part of this visibility solution provider, we need to find ways in which we can track those pods, make sure that we can extract right information from those pods and create a smart data, okay? On top of it, we have another problem. Now, encryption is a good thing. We want that encryption to be there, but it actually is an enemy for visibility as well. So if you see that what we see and what we observe in the networks of the future, there are two ways of implementing. One is a way in which there is built-in. The network function actually sends the traffic to another network function in an encrypted manner. And there is another way, which is a service mesh way. In this case, we have a sidecar. So this actually helps resources, but again, the problem doesn't go away. What we see is that there is a lot of encrypted traffic seen. It becomes difficult to provide visibility if the traffic is encrypted. So as again a solution provider, we have to make sure we find ways so that we can bring visibility to do that. And if you see that, again on top of it, because the specs are very new and there are different ways of implementing, we see a lot of non-standardized information actually getting implemented right now as we are embracing the networks of the future. There is a lot of vendor dependency as well. And if you see, we need to address these problems. And as a solution provider, we need to make sure that we embrace these properties in the solution, which include reassembly, load balancing, and making sure that if there are packets which are going out of order, we are able to make, I will say, sense of those things and information. Not an easy job at the scale that we are talking now. Also, how do we achieve the vendor independence? So as a solution provider, we should have various plugins available where we understand that we simply understand if there is, say, an Ericsson, Nokia, or Oracle, or Cisco, or Aspen, various vendors which are available. The solution should actually embrace all these various deployments factors and present a harmonized way of information to bring visibility to the service providers. What newer complexity that we see is that if you see a typical network function, there is a producer, there is a consumer. The problem is that IPs are getting repeated, there is a lot of NATing happening. So in the conventional way of the things, we were tracking information from IPs. So IPs are, in the future networks, IPs are also getting challenged. So how do we do that? There is a lot of issue to bring visibility, and I will show you there are newer specs that are available. There is this newer thing called NF instance IDs, network function instance IDs, which generally are 64 bits or 128 bits. If I have to call it, they are the newer avatars of the IP addresses in the CNF or cloud native functions. So we need to understand and how we make sense of the data from that perspective. So if we don't embrace that, the visibility is still incomplete. That doesn't really help. So if you see and look, we have new RFCs 4122, for example, newer which is writing this NFIDs, which is helping us or enabling us to circumvent where the NATing problem or IP repeating in the cloud native function is causing an issue. So we as a solution provider has figured out and have closely worked with various vendors and really helped in developing these specs so that we can enable the solutions of the future. So how does it actually look like? From a simplifying way, it's just a newer table. From an end user perspective, nothing changes. You would have seen DNS, right? DNS is a simple way of converting IP addresses to names, right? So that humans can really understand that. In a similar fashion, what we have done is that we are in the cloud native environment. We are doing a similar approach where NFIDs are actually getting associated with names so that the workflows or things that the users are used to that really don't change, right? So we as a solution provider are trying to remove these barriers, and we are working very hard to solve these tougher problems, to embrace the networks of the future, right? So solutions need to be cloud native ready. They are not the same what we see or we have been having in the conventional way of the things, right? And the solution natively needs to embrace a situation where there will be encrypted traffic. So they need to find ways to provide visibility even if the traffic is encrypted. It's a very difficult problem, right? The whole purpose of encryption is to make sure nobody can read that information. But that's where more, I will say, associations and more, we have to work very closely with various vendors, and there has to be more harmony in the industry to make sure that how we can use that. right? This is not an easy task again. And how we embrace the complex, newer age plumbing or network plumbing. So the solution needs to natively approach that. So let's talk about smart data right now. So I will come back to that, why I'm talking about smart data. So a smart data is a way which gives you multi-dimensional intelligence. It can be any technology. It can be a fixed network. It can be a 5G standalone network in the cloud function. There can be applications in AWS which are on the public cloud, or it can be a legacy system like a 2G or a 3G network. They are still here. We have to embrace them. It actually adds to the chaos, not an easy task to maintain, build a future-proof solution which embraces both legacy and the future. Also, it needs to be very, very granular on per subscriber basis. Look at the number of transactions. We don't even realize that how much of data or metadata is getting generated because of any activity on the network by millions, if not billions, of subscribers on the network. So really big data systems are needed, and we have to go into the granular aspect of each subscriber. It has to be multidimensional. What locations, cell IDs, what type of handsets are being used. Look at the diversity and look at the way even the handset ecosystem has changed over the years. We need to make sure that we embrace all those changes in our smart data, right? And also, we need to make sure that when we are looking at all this data, how quickly any transaction is actually getting made, or what protocols are actually getting used in delivering that service, right? So we need to embrace those dimensions as well when we are creating these smart data. Also, we need to be fully aware of the situation that sometimes, and these are again hybrid networks and these are modern times, virtualization where a lot of decoupling of the software from the hardware has happened. So we need to embrace that change as well, and also be part of the ecosystem where we can take data from different APIs. That means the applications are talking to a different application. Also, we can feed it into that particular different application. So it's the ecosystem that makes the whole visibility much more smarter. That's how, these are the fundamentals for the future, how AI and ML has to work. A lot of people you will hear or see that they talk about AI and ML, but if the data source is not right, it's garbage in and garbage out. So machine learning and AI doesn't really work if your data is not very granular and accurate. And all this is coming from a single source of truth, that is the packets. So what exactly is a packet? Packet, is what runs the internet, right? They are what is on the wire. Many organizations have tried making sense of SNMPs, net flows, syslogs. A lot of, I will say, integration has been done to achieve that, but nothing can replace the true beauty of a packet. Packet gives you information from layer 1 to layer 7. So a lot of use cases can be delivered when you are looking at the packet itself. So this is what comprises of a smart data. So how to approach the modern analytics to provide visibility to various service providers who are working at that scale where it's crazy numbers. The users are in millions, if not billions. The data rates are going off the roof. I can't even talk about mathematically right now. So how do we approach that? There has to be sophisticated ways, and also we have to make sure the data is accurate and it is providing you enough information that you can build the use cases and workflows of the future and embrace all the changes. So at the heart of this, we have to work on the packets. We have learned, we have realized that nothing is more amazing than the packet data. And on top of it, when you have machines which are creating metadata, which is a smart data, which I talked about, they feed into an ecosystem of applications which are machine learned and having artificial intelligence. These are no longer the buzzwords. These are realistic things. So I will show you how there are different approaches that can be done to solve the problems in an automated way. Because humans are not able to scale up to these numbers. So how do we have to address visibility without borders? That is the key, because the solutions that we are talking now need to be ready for the future, and we don't know what is coming after 5G. What other, and some gentleman was talking about quantum computing. It's mind-boggling, and I will say amazing times, and we are again going back to the board where whole fundamental of the way we are computing is going to change eventually. So we need to make sure that we are in a stage where we can embrace such disruptive technologies of the future. So any network, it should have, it should embrace any cloud, can be a bare metal, your regular data center as well. Should be embracing any vendor. It has to be democratic. And it should embrace any service which is possibly a voice, data, IoT devices, autonomous cars, and name the service, it should make sense of that data. Another piece I will like to add is that correlation. For a long time, what we have observed is that if we look at data in silos, we reach to a wrong conclusion. So it is very important that we find a way or a mechanism in which we correlate the data. To show you an example, it's like looking at an elephant in the dark, right? A person can be assuming that it looks like a fan or a rope, but actually it's an elephant, right? So we need to make sure, and we need to understand that how powerful data becomes when it is correlated, okay? As an example to show you, I want to show you a typical example in which if there are users, you all make calls, right? And Volti you guys have been using it for a long time now, right? But if there is a problem, look at the pain the service provider has to go through. There are no simple functions anymore. There are multiple hops. And if we go with the conventional wisdom, where we are looking at, for example, only in the IMS core, what we will see or observe is that there are SIP headers or reason codes that we observe. Sometimes they point us in a direction. Most of the times they are so generic that we cannot do anything about it. So, for example, in this case, the SIP reason header is RTP, RTCP timeout. Nobody can say what the problem is because of that. But if we start to correlate the radio messages with the core messages, something really beautiful happens. The core side of monitoring or data, smart data, shows us MOS is really poor. Okay, we understand that MOS is poor. But however, now it also shows you the power of the UE that is getting reported is really low. Okay, that is giving me much more information. If I further dig down deep, it tells me that the reason is because of the poor coverage. So I am actually finding the real cause which was overlooked if I was looking the data in silos. This is the power of correlation. So, and now This was the conventional way of doing things, yeah? But now we are approaching a way where the scales are so high. So automation is no longer a choice. If we have to manage things, automation is needed. And humans, we cannot find those many needles in the haystack. It's not humanly possible. That's why solution providers need to aspire to make systems which are not only AI ML driven, but they are delivering use cases which are actionable business intelligence, which is leading to automation, right? So I'm now going to show you an example in which a possible solution, how it can deliver value in a different way, which is kind of in an automation way. As you know, just to show you, this is a typical network where we have, can be a 4G or a 5G. There are core nodes as well involved in this. So how do we apply that? So the solution needs to quantify that if something is broken, how many users are getting impacted because of that? Unless or until you don't quantify that, you cannot really prioritize that. So that's an important part of the puzzle. Also, it should be able to tell that if it is the outlier or if it sees that behavior getting repeated in other nodes or other functions as well. Also, it should have a deeper way. It should actually tell you, is it what kind of nodes? Are we talking only specific geographies, cells maybe? Or is it a typical specific handsets? So it should tell you in a way that it guides you, that it shows and reveals a pattern, right? And that's where, and it has to be correlated, no doubts about it. And it should present it itself in the GUI in a way which is intuitive to the human beings, right? So that becomes an important piece. But if you want to do a closed loop analytics, it should also be able to feed to other applications as well, right? So if I have to show you an example, right? So in this case, if you see that this is a dashboard, it shows that I'm hopeful that you're able to see. Audio gaps, for example, that those are the outliers, and also there are call setup issues. Rest of other things are still okay, right? It reveals itself that how many subscribers are actually getting impacted, right? And if I dig down deeper, I can simply click, and it should tell you what's really happening. Is that the next granular information, it should tell you that it's the audio or the MOS is getting impacted. What we see or observe, for example, is during handovers. So it is not just any call is getting impacted. We see a pattern here. It's because of the handovers. And also another pattern that we observe in this case, for example, is that it's during the middle conversation. It's not happening in the start or in the end. It's during the middle of the conversation. Also, another pattern that reveals is that there are certain geographies or cells revealing themselves that it's a geographic problem, not a complete network problem. So once the analytics platform shows you these patterns, you will be able to comprehend information in a much better way, which is scalable. At that data rates, it becomes easily manageable. Otherwise, it is very difficult. So what really we are going towards, so correlated data and automation, these are the fundamentals, right? So it should tell you that what's the business impact, how many users are getting impacted. It should also tell you about all the know-how the analytics, because you have diversified networks. So there will be a different know-how what's happening in a fixed network as compared to a network that is a 5G standalone, for example. All this best practices, know-how should be built into the ecosystem. Machine learning, so the system needs to learn and understand what's really going on. Gone are those days where you could create certain alerts on basic thresholds. We don't want to get into those situations. We want machines to learn the traffic patterns and spit out information that this looks to be a situation in your network, and it should guide and tell, and there has to be mechanisms in place where there are no false positives. So we need to make sure that all these factors are embraced in the solution of the futures. Also, deeper analytics, multiple dimensionals, revealing a pattern itself, and gives you smart outcomes. Possibly an API integration, which is taking some kind of an action based on that. So there is closed loop analytics. This is how we can actually embrace and make more sense of the data. Otherwise, we will be in a situation where it's too much of data, which is causing a lot of chaos. We are looking at it in silos and not able to comprehend or make sense of it. So we need to embrace and have solutions according to that. Again, we all are in resource crunch. Same people, they are maintaining the legacy networks or networks of the future. They need to quickly scale up. The solutions need to be simplified, and they should embrace all this hybrid networks and situations. So the same users can solve, or same users can solve the problems of the various other subscribers. So this is a key aspect as well. So what we aspire to do, we want to remove all these barriers where we need to embrace the cloud native functions, AI, ML, automation. These are not the buzzwords, they are real solutions are there which needs to give that workflow, because humans cannot scale to those levels. We just simply cannot. We need to provide that, we need to take care of those encryption as well. So there are solution providers who know and can embrace and can remove all those barriers. And whatever I'm showing or talking is real stuff. So what are the key takeaways finally? The solution needs to be vendor agnostic, cloud native function ready, and should work with packet data, which is so sacrosanct and is the ultimate source of truth. I don't have anything else, but thank you very much. I hope it was useful.
Thank you, Manuj.
And you can ask me questions now.
Thank you. Do we have any questions? Oh, we have one question. To the mic, please.
I can't hear you, Ahmed, sorry.
Hello?
Yes, I can hear
Yeah,
you.
my name is Ahmed from Dubai. There is, in one of your slides, you have mentioned when you are trying to, the challenge of nothing, and then you are putting some new technique of naming. Can you open that slide?
Yeah. That's NF instance IDs.
Yes, is it the standard one, or this is your...
So NFIDs are standards. I showed you RF, there are RFCs on that. But what we are doing is that we are making use of those NFIDs and putting a name to that in a similar way what we used to do for IP. And in the DNS side of the world, we are using similar techniques so that, because what we have seen in cloud native architecture, the IPs are changing, they are transient. So how do we embrace that? This is the way, or we have found a way to do that.
Okay. So even how did you check about the use of IPv6 in the same way?
Sorry?
The use of IPv6.
So IPv6, the problem is that IPv6 in the cloud native function, the challenge is that there are producers and consumers, right? The number one problem is that we can see or identify when we are listening to that producer, we can see the IP. It can be IPv4 or IPv6. The problem becomes that even if, and then we have the consumer who is taking that data, that at times is netted. So we are not able to establish that what was the request and where the response came from. So if we keep on tracking using even in IPv6, we are not able to give you the complete visibility for request and response. So NFIDs are what we have found out, they stay consistent.
Okay, good. But how will be the issue of the
Closer
privacy?
to the mic, please.
The issue of the privacy, because now you are going to identify the end user.
No, NFIDs are not showing you the end user. They are just related to the functions. So we are not tracking to that level. These are messages on the service levels that we comprehend, and also there are other techniques in which if you want to do masking of end users, even if we do the correlation in the system and all, it cannot be, we can have techniques where we can refrain from users looking into that data.
Okay, thank you.
Thank you.
Thank you. No more questions in the room? Thank you, Manuj. That was a very insightful presentation.
Thank you very much. Have a nice day, guys.